delta.
Very good. Keep one thing in mind, and this is going to make this whole calculation easier for you, that almost all, not all, double displacement reactions, the displacement reactions of the sort where two displacements occur simultaneously, and we actually classify them as two different reactions. One of them is neutralization, in which acid and alkali reacts to produce salt and water. Two displacements occur at the same time, in which two spectator ions displace one another and H and OH displace one another to form water. The second one of this sort is precipitation, in which two soluble salts react to form a soluble salt and an insoluble salt, or what we call a precipitate. So both of these kinds are not redox reactions. They simply displace one another, so they tend to not change their states. Now, in both these cases, you don't have to go through an entire calculation. You can do it to be on the safe side, but if that's a simultaneous two displacements at the same time, probably neutralization or precipitation, there won't be any reduction oxidation changes. So one is the only answer. Since second one is a simple displacement reaction, and the third one is a precipitation reaction.
Yes.
Okay. So moving on. Too easy. Too easy. Not as easy as the previous one, but definitely you'll be able to do it. Easy. Easy. All right, let's go with 60. This one's different. I'm not saying it's easy or difficult, but this one's different.
Alpha.
No, think again.
Sulfite is CaSO3.
Sulfide, SO3 negative 2.
Yeah. SO3 negative 2. Oh. Okay, then
it's
beta.
Just an ion. Then beta, right? Okay, because last is not correct for sulfide.
Yeah.
David. Too easy. Okay, 64.
Beta.
How did you deduce that 3 is incorrect?
Yeah, I did 3 is incorrect. The statement number 3, because the chloride isn't a good reducing agent. So alpha and Charlie are wrong. And then the bromidine and iodine, they act as reducing agents. And in both of them, they further react with the, what's it called? Sulfuric acid, I think. And then they form the other products. So
Right.
first statement, I think that's correct.
Right. Good. Too easy. Let's go with these multiple topics. Yeah, let's start with one. Multiple topics are sometimes the MCQs which are a little bit out of the scope. So you have to think about it and come up with a decision that is probably not already a part of the book.
All right.
So go ahead. By the way, MCQ number 1 has a lot to do with chapter number 27 of A2. But again, what you have done back in the bonding chapter, you can jump to a conclusion.
Mm-hmm. Delta.
Very good. Why do you think A is incorrect?
It will be non-polar, since both are the similar atoms. So there will be no difference in electronegativity.
Good. What about B?
In the N2 molecule, there's one lone pair.
Actually, there are 2. One lone pair on per nitrogen. If you're talking about one atom, that is
per
correct.
nitrogen, yeah.
That is correct. What about C?
C would be, it should not be plus, it should be negative something, because hydrogen is plus, it would be then
Negative
-2.
-2.
Yeah.
Very good. Very good. Well done. 2. And 2 is pretty much a repeated MCQ. I hope that's clear from a lot of numbers shown on top of the question.
Beta.
Perfect. Okay, 3. 3 is too easy. Get it. 4.
Delta.
No, that's not it. Think again. Either one from 2 or 3 is right. I'm not saying A is the option, but D is not
Yeah, Alpha and
also.
Charlie are wrong. Yeah. So then it would be beta then. But wait, let me see how that beta. Okay. Okay, I get it. Yeah, because the product form would be increasing because both the conditions are favoring towards the product side.
Okay, remember the fact that equilibrium constant is not affected by any of the other conditions, catalyst, pressure, concentration, surface area, but it is affected by temperature.
By temperature.
And temperature, as per the type of reaction, whether it's exothermic or endothermic, and however the Lee-Shakespeare principle applies, if the reaction is moving in forward direction after the temperature increase or decrease for the type of reaction, the equilibrium constant increases for forward reaction and decreases for reverse. Now this reaction is exothermic and the temperature is decreasing, so the reaction should move in forward direction because the concentration is also increasing. So temperatures decrease will take the reaction in forward direction, hence equilibrium constant increases. All right. Good.